Alrighty, so far we might have noticed some weird, funny things happening with complementary angles. Let me show a complementary angle that we are already aware of. For example, 60 and 30. We call them complementary because when we add them together, we get 90. However, because we're also dealing with radians, it could mean that they add to pi on 2 instead. Alrighty, so let's really quickly, this is the 1, 2, square root 3 triangle. Let's just have a notice of some of the interesting behavior that happens here. So if I have sine of 60, and then I work out the cosine of the complementary angle, 30, what do we notice about these two values? We've already noticed this probably accidentally, but sine is opposite over hypotenuse. Oop, that's not a highlighter. So opposite over hypotenuse, square root of 3 on 2. And if we go for the cosine of 30, it's going to be adjacent over hypotenuse. Weird. And in fact, you can test this with any two complementary angles, is that the sine of theta is going to be equal to the cosine of its complement, which is 90 minus theta, and vice versa. Remember, this is in degrees. In radians, it works exactly the same, except 90 in radians is pi on 2. But just so we're aware. Alrighty, so let's actually have a crack at doing this one. So we know that cos of 35 is equal to 0.82. Determine the value of sine of 125. We might go, those don't look like complements. But we need to be mindful that some things are not always as they seem. So let's draw them. Cos of 35 is a relatively small angle. And you can see here that we're going to get quite a long cosine, but quite a short sine. We don't actually know the y-coordinate, we only know the x-coordinate, 0.82, comma something. And then we've been given the sine of 125. Well, 125 is actually bigger than 90, so it's actually going to be up here. And once again, we can go through and draw in our two lines there. But you can see here that the blue side that we knew before actually matches up with the red side we know now. It means that the height is going to be 0.82. The other way we can think about it is that then what is this reference angle? Well, the sine of 125, well, all stations to central, it's going to be positive. It is in the positive quadrant. And it's going to be sine of, well, 180 minus 125, which is the sine of 55 degrees. But wait, what does our rule say? Well, the complement of 55 is just the cos of 55. Is going to be the same as cos of 90 minus 55, which is cos of 35, which we already knew from before is 0.82. So I've got two proofs there that work. One using these rules, and the other one just using a visual proof. We can see that the long side was previously the x-coordinate, but now it is the y-coordinate. And because we're in the positive y area, it's going to be positive. So either option works perfectly fine, just different ways of thinking about it. Alrighty, I'll see you in the next one. Goodbye.